Hello, good morning, viewers. Let us solve this problem involving differential calculus. We are given that u equal to 3x squared and v equal to negative 7x to the power of 3 over 5. And we are asked to find the derivative of these 5 problems. So we are going to start with the first one, which is the derivative of u minus v. All we have to do here is to substitute the value of u and v, then differentiate. All right. So the first one, we want to differentiate u minus v. This is equal to d over dx of u, which is 3x squared minus v, and v is negative 7x to the power of 3 over 5. We already have another minus, so this becomes plus 7x to the power of 3 over 5. So let's differentiate them term by term. So this is equal to, you take 2, which is the power of x, then you multiply by 3, you get 6. X to the power of 2 minus 1, which is the same thing as x. Then you add, you take this power 3 over 5, then you multiply by 7. That will give us 21 over 5. So we have 21 divided by 5. Then x to the power of 3 over 5 minus 1. So let me compute that. 3 over 5 minus 1, and 1 can be written as 5 over 5. So this is equal to negative 2 over 5. So the power of x is negative 2 over 5, which is going to give us 6x plus 21 divided by 5 multiplied by the fifth root of x to the power of 2. All right, let us move on to the second problem. The second problem, we want to find the derivative of u multiplied by v. All right. We want to find d over dx of uv. We don't have to apply product rule here. We can just use one of the laws of indices to simplify uv. Then we take the derivative. This is equal to d over dx of u, which is 3x squared, multiplied by negative 7x to the power of 3 over 5. This is equal to d over dx of 3 multiplied by negative 7 is negative 21. Then x to the power of 2 plus 3 over 5, which is the same thing as 13 over 5. So this is 13 over 5. Now we are free to differentiate. This is equal to, this power of 13 over 5 will multiply negative 21, and that will give us negative 273 divided by 5. Negative 273 divided by 5. Then x to the power of 13 over 5 minus 1, which is the same thing as 8 over 5. So this is the derivative of uv. Let us move on to question number 3. Question number 3, we want to find the derivative of sine u multiplied by cos v. D over dx of sine u multiplied by cos v. All right, this is equal to d over dx of sine 3x squared, then multiply by cos of negative 7x to the power of 3 over 5. This time around, we have to apply product rule. This is equal to, let us keep this function constant, then differentiate this. So sine of 3x squared constant multiplied by the derivative of this. Now observe something. We have inner and outer function. Therefore, we are going to apply chain rule. We differentiate the inner function which is negative 7x to the power of 3 over 5. If you differentiate that, you're going to obtain negative 21 over 5 raised to the power of negative 2 over 5. Negative 21 divided by 5, x to the power of 3 over 5 minus 1, which is negative 2 over 5. Then you multiply by the outer function, which is cos of this function, and that will give us negative sine of that function. We add. This time around, we are going to keep this constant, then we differentiate this. So we have cos of negative 7x to the power of 3 over 5 constant. Then we multiply by the derivative of this. Let me start with the inner function, 3x squared. That will give us 6x. Then you multiply by the outer function. Sine of that function will be cos of that function. Okay, now let us rearrange this. From here, you can see we have a negative sign here. We also have another negative sign here. So if they multiply, they become positive. This is equal to 21 divided by 5, x to the power of negative 2 over 5. Then you multiply that by sine of 3x squared. Then the other one, sine of negative 7 x to the power of 3 over 5. Okay, then plus, let me write this first, 6x multiplied by cos of negative 7x to the power of 3 over 5, then multiply by cos of 3x squared. So this is the derivative of sine u multiplied by cos v. So now let us move on to question number 4. Question number 4, we want to find the derivative of the hyperbolic sine of u, which is sin u. So d over dx of sin u, this is equal to d over dx of sin u, remember, is 3x squared. All right, we are going to apply chain rule here. This is equal to, let us take the derivative of the inner function first, which is 3x squared. That will give us 6x. Then we multiply by a derivative of sin 3x squared, which is going to give us cos 3x squared. Cos 3x squared. So this is just the derivative of hyperbolic sine of u. Let us move on to the last one. The last one, we want to find the derivative of u divided by v. D over dx of u divided by v. This is equal to d over dx of u, which is 3x squared, divided by v, which is negative 7x to the power of 3 over 5. We don't have to apply quotient rule here because we can use one of the laws of indices to simplify this. And this becomes d over dx of negative 3 over 7 x to the power of 2 minus 3 over 5. And this is equal to 7 over 5 because 5 multiplied by 2 is 10 and 10 minus 3 is 7 divided by 5. So this is 7 divided by 5. Now we are going to take the derivative. We take this power, we multiply by this constant. We have negative 3 over 7 multiplied by 7 over 5 multiplied by x to the power of 7 over 5 minus 5 over 5, which is the same thing as 1, right? So this is 2 over 5. 2 over 5. From here, 7 will cancel 7. All we have left is negative 3 over 5. Negative 3 over 5 x to the power of 2 over 5. So this is the derivative of u divided by v. And this is all I have for you today. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.